So my name is Zach. How many of you have seen the film Chasing Coral? That's usually a good start. Sweet. So probably 50-50. The film was actually made in Boulder. I grew up here in Colorado, went to Pomona High School, have a degree in evolutionary biology from CU. And my world was totally turned upside down by this experience that I had. I was 22 years old when I started on the project. I worked for it on 4 years, all over the world, spent very little time in America over that time span. And basically our idea was based around how our oceans are changing. And more importantly, how can we take a world that is out of sight and out of mind for the average person, particularly in a place like Colorado, and share that with the average person, with the general public, and be able to visually show everybody how these things happen and what it looks like. And so this project actually started with 2 photographs. This was the first one that was sent to us. This is a healthy, functional coral reef ecosystem in the Great Barrier Reef. This is what it's supposed to look like. And the email also included this photograph. This is a coral reef that has gone through a bleaching event. Essentially, all of the corals perish, and their skeletons essentially get eroded and degraded over a matter of about a year, and you end up with what we call a rubble field, which is what you're seeing in this image. And immediately, there was this idea that we were going to replicate the film Chasing Ice, if you guys are familiar with that, but to do that underwater. Now, I got involved because I've worked in the aquarium industry on corals basically my entire life. I actually work at a local coral reef shop. We grow and aquaculture corals for aquarists, hobbyists that have coral reef tanks in their homes. I did that throughout high school, throughout college. As I was graduating college, I actually quit that job, and I began a job where basically the job that I took was to engage myself further with coral reefs. So I took a job at a company in Boulder called View Into the Blue, where we build underwater imagery equipment for scientists around the world. Essentially, it's a self-cleaning housing. The biggest issue that marine biologists face is if you want to take pictures underwater, you have to physically be there because the calcification process takes 11 hours. So if you take a camera, put it underwater, the next day your images are junk. They're covered in algae, they're covered in calcifying organisms. The idea on a marine ecosystem is a competition for space. Everything is constantly trying to live everywhere. So we design a system that cleans itself so we can have long-term imagery for scientists and allow them to not have to be in the field 24/7. Now, as soon as I got that job, I met this guy. His name's Jeff Rago. He's the director that made the film, and he had previously done this project in the Arctic. He set out cameras, some of them still exist today, and took time lapses of glaciers melting for over 7 years, and that's how he made that film. And the beautiful thing about it was really the first time that we were able to really create something digestible to allow the natural public to see these things happen. When you say, oh, the glaciers are melting, but it takes 7 years to really see it. It's hard to do that unless you can fit a time lapse, change the way that our perspective is with ice. And he wanted to embark on this journey. And it so happens that if you want to do that and take a long-term time lapse, you run into the problem of cameras being underwater and getting really dirty. And I happened to fix that problem. So we met up, we created this entire plan. I designed these cameras basically from scratch. It took us about 6 months to get the first prototypes. And then we embarked on this journey all around the world for 4 years. I spent 700 hours underwater over those 4 years, filming coral reefs around the world and trying to capture this elusive event. Now, I'm going to talk briefly about kind of the entire process of the film, our thinking, where we failed, where we had successes, and really the journey as a whole. And then the second half of the conversation is going to be kind of about my learnings and where I think we're heading and kind of the beautiful things we did with the film after the fact that has given me a little bit more hope for our oceans. Now this picture is really important because my assumption is everybody in this room has no idea how a coral functions. But corals are really fascinating. They actually are animals, but they actually don't need to eat. They don't need to eat any food because they actually enslave an algae or a type of plant inside their tissue. So when you look on here and you kind of see these wiggly patterns on top of the coral, that's actually a species of algae that the coral has inside of its tissue, and that algae provides all of the energy that the coral needs, and that allows the corals to grow, it builds their skeletons, allows them to survive. That is the core of this. I joke with children when I do this that if it were me and you, instead of having our our lunch break at the cafeteria, we would be going outside and sunbathing for 4 hours, and that would make us grow big and strong. That's essentially how a coral functions. The catch here is corals are living in a very, very particular set of parameters. They need the temperatures to be very stable, their lighting conditions need to be very stable, and it has to be really clean water. When things get too warm, this algae starts to misbehave. Instead of producing energy and food for the coral organism to live and grow and thrive, it actually starts to produce really nasty molecules. And I'm not going to get too deep into the science, but basically the coral recognizes I've got something inside of me that's doing something that is not normal and it's actually hurting me, and the coral spits out its source of energy, and it leaves behind their white tissues. So corals, we all think of these quintessentially beautiful coral reefs, colors are endless. Well, corals are pigmentless. The colors you're seeing are the algae and the algae only. So during these warming events, when we get a bleaching event, they spit out that algae and they leave behind nothing but endless white skeletons. Now, it's not to say the biggest misconception here is that coral's not dead. It's the coral, it's tissue, but it's suffering. Essentially, it's starving to death. And if a month or more of this heat or temperature anomaly continues, that coral will starve to death and then ultimately die. So our idea was we're going to set up these cameras, we're going to go all over the world, we're going to put them underwater, and hopefully we're going to be able to capture this beautiful ecosystem, essentially turn into a rubble field. Now, when we began doing this in Australia, so I lived in Australia for about half a year during the filmmaking. This is a data set from 1998 and 2002. They're the two previous mass bleaching events that happened in Australia. The red is where we had mass bleaching during those years. Green means that things were fairly stabilized. If you're me, where do you think we're going to want to put our cameras based on the history of bleaching in Australia? I wish we had done that, but historically we put them where the red was. Historically, I know that the South bleaches during bleaching events, so our idea was, well, let's go where bleaching tends to happen, and we're going to hopefully capture it. Unfortunately, that's exactly what we did. This is a camera in the Keppel Islands, which is actually located right about there. But in 2016, that's what it looked like. So everything that we had worked for all of the time and prototyping on my cameras were all for naught. Basically everything in the South survived in 2016, so we had to change everything that we were doing. And the way that we did that was we flew up to the north with no cameras, and we did everything by hand. So this was my life for about 60 days. 6 hours a day underwater, going to about 55 different locations of corals and taking the same 5 minutes of footage. Literally waking up, having breakfast, getting in the water for 3 hours, having lunch, getting in the water for 3 hours, going to bed was my life for 55 days. But we were able to actually capture the world's first bleaching event. Now, this is the first ever time-lapse ever taken on a coral reef during a bleaching event. If you guys have seen the film, you've obviously seen a handful of these. But this was a site for me that meant a lot. On the final days when we came back there, this is a site that made me cry in my mask, scuba diving, because there was so much diversity at this location. So I'm just going to let it play and allow you guys to watch. Oops. So you can see the death taking over there.
What period of time is this?
55 days. So essentially we've gone from in just essentially a month and a half, a fully functional ecosystem to complete ecosystem collapse. The only thing that are left on these ecosystems are herbivorous fish. They actually win because as these things happen, all of those brand new coral skeletons coming back to the cameras are new space. And algae actually takes over and we get what's called an algal turf. And so any herbivorous fish is basically having a party. They've got an unlimited food supply. They're the winners. But anything else on that ecosystem, fish that rely on these coral colonies, fish that feed on coral colonies, and then other fish that feed on those fish have all been wiped clean, essentially. Now, to put this into perspective, Part of the problem here is not only us warming our planet, it's also really key to understand that these bleaching events aren't happening every year yet. They're happening when it's paired with an El Nino event. And an El Nino event causes an abnormality in temperatures of waters on coral reefs around the world anyways. It's only within the last 30 years that they've begun to cause massive bleaching worldwide. Now, in 1998 and 1997, we had the first ever mass coral bleaching event that is in recorded history. In 2016, we had a secondary event, and it was not even close to being on par with 98. It is so much worse, and so I'm going to play this video so that you can see kind of the perspective. Obviously, red is bad, and in 2016, really 2015 through 2017, we basically did not have a single centimeter of ocean on our planet that did not see anomalies in temperature that wouldn't kill corals. And the next diagram that I'll show you will actually prove that as well. I really just show this to put into perspective that the severity of these El Niños are being exacerbated by our actions. As we continue to warm this planet, an El Nino is going far beyond the tipping point of what a coral reef is able to handle. And our most recent research suggests that by 2043, every coral reef on the planet will see bleaching-like tendencies on a yearly basis.
What are the trends of El Niños as far as years?
Yeah, so El Nino is a natural process on our planet. So they happen anywhere from 7 to 10 years apart from each other. Obviously, there's variables in that, but it is part of a natural process that exists on our planet. Sure, absolutely. But unfortunately, as we've warming the waters anyways, right? So as the El Niños happen, then we're really just setting that bar so high that the corals can't keep up. This is a diagram to show a concatenation of data from June 2014 through 2017. You'll notice that there's supposed to be this little blue bar of no stress. That does not exist on our planet during that time period. Nowhere on the planet was a coral able to survive. Now, that's the idea behind chasing coral, but I want to remind everybody that perspective is everything when we're talking about these things. So many of us watch these documentaries where it's talking heads and scientists shooting us numbers, graphs. Those things don't resonate with the average person. You have to change the way they're seeing things. And corals, to most people, are pretty rocks that live underwater, right? They don't think of them as animals, but they are these incredibly beautiful places. And I think it's really hard for somebody to experience them or to learn about them and not have some curiosity or fall in love with them. And the second part is, we live in a time and an age where we're getting information in little 30-second snippets all the time. We're bombarded by it. Everything is at our fingertips. But the rest of the world, the rest of nature, lives life in the slow lane. Things are very slow moving in the natural world. And that's with corals. I can take something like this video, where this is probably over 30 minutes or so. You know, taking 30 minutes and putting it into a little 10-second snippet where you can actually see them move, they feed, they fight with each other, they reproduce. They do all of the things that animals do, they just don't do it at our speed. That doesn't make them any less important. I'm gonna play the trailer to the movie now just to briefly give anybody that hasn't seen the film an idea of what the film was about and a little bit of it in general, but then we're going to talk a little bit about how we took this film and what we were able to do with it.
I have the utmost respect for corals. They're really sophisticated animals.
Coral is a fundamental part of a huge ecosystem.
They continue living as long as their environment allows them to.
There's this big heat wave that's traveling around all over the world. The coral bleaches, and what you're seeing is its skeleton underneath. It's like your body temperature changing. That's the seriousness of the issue. So we're sending 2 teams to put cameras down and capture this bleaching event.
The wind and the storms is really the controlling factor right now.
The wind just took us. The stern anchor didn't hold.
It's just demolished. You're working in an environment every single day that humans weren't built for. Your body is cut up, and then you open your eyes, and it's dead as far as you can see.
We don't have any time to waste.
If we want to have any hope,
we live at a unique moment in time where we can change history. It's not too late for coral reefs.
This has got to wake up the world.
Cool, so if you haven't seen it, obviously it's on Netflix. And part of that is what I'm so proud about. We released this film at the Sundance Film Festival in 2016. We won the Audience Award, which is a huge, huge deal that, quite frankly, at the time I didn't really understand. We went on to get shortlisted for the Oscars. We won an Emmy Award. We won a Peabody Award. We were able to spread this story around the world. And quite frankly, before 2015, if you were to Google coral bleaching, you're going to find 1 or 2 really grainy photos taken by scientists in 1998. It wasn't until this event where we had people on the ground all over the world actively trying to capture this that now the average person knows that these things are happening in our oceans, and it's commonly talked about. And we've been on the front page of Time Magazine and the Washington Post, etc. We brought this into the picture for people. And for that, I'm really quite proud. But the takeaways from this journey for me have been unbelievably extensive. And part of it is that working with scientists from all over the world, scientists are not good communicators. A lot of the time they know so much that they're unable to communicate it to the general public, and that's part of the problem, paired with the fact that most of it's going on behind closed doors. The average scientific journal is $100 to read an article. That doesn't make it easy for us to understand these issues, to understand climate change, because it's not available to us. And part of that is the way that we talk about it. And part of that is just the way humans work. We crave things to be boxed into categories, and we really like when things are black and white, yes and no. And quite frankly, that's not the way the real world works. For example, during the heat of this event that was happening in Australia, these are 2 drastically different arguments. On the left, you have an obituary for the Great Barrier Reef, basically claiming that the entire thing is dead. That's not exactly the case. Yes, 50% of corals died in 2016 and 2017 in Australia, but that's not to say that there aren't amazing coral reefs still existing. The Great Barrier Reef is the length of the east coast of the United States. There are 4,600 individual islands and reefs that make up this structure. Not every single one is impacted in the same way, some worse than others, certainly. But then on the other side, you have people saying that everything is fine. And that's how we get clicks. That's how we talk to people. We have to be so distant and so polarized in the way that we communicate nowadays that the truth is really hard to convince people to when it comes to science, because everything's a gray area at the end of the day. And that couldn't be more well represented than the surveys that we did after the bleaching events. Up here in the north, where you see this red area, we expected to see really nothing but absolute destruction up there. And while that was mostly the case, it wasn't the case everywhere. And then on the far outer ranges, where they have access to cooler water from the Coral Sea, we expected to see everything in pretty good shape. And that was mostly the case, but not the full story. So I want to show you some images from those locations. These first ones are going to be from the inner reefs. Here you can see complete devastation. There's not a single living thing inside of this photograph. And that was the case in the vast majority of the inside of the reef. You can see a couple small fish, a starfish, maybe a couple living corals here and there. But then we found this. Inshore, should have been dead. We don't have a reason why this coral reef is still alive. Pretty mucky water. Not really a beautiful dive by any means, but the coral coverage was massive. We're talking 98% coral coverage, a beautiful, flourishing coral reef system amongst death everywhere else around it. And these reefs, as we'll talk about here in a moment, are really important for us from a scientific perspective. Now, secondarily, on the exterior of the reef, we're finding things like this, a beautiful ecosystem. In fact, this coral reef in particular was so extensively covered in coral that we actually think it's the most diverse Acropora, which is a species of coral site on the Great Barrier Reef, ever found. And we discovered the new first species of coral to be discovered in over 30 years while we were on this dive. This is actually a coral that is a coral reef growing on top of another coral. This is a giant coral that's about 1,400 years old, actually predates Captain Cook getting to Australia. and it's got a microcosm coral reef growing on top of it. There are still incredible places down there. And then this is actually in the same location where you have massive mortality. So everything, there's no black or white when it comes to coral reef biology. Every individual reef has its own hydrology, its own story, its own factors that are playing roles into whether or not it survives or doesn't. Now, the second part of science communication outside of the data is how we portray scientists in the first place. So much of the imagery that we think of with science is serious faces, working very hard, lab coats, beakers, statistics, numbers, all of the things we think about. And you can see that in a lot of these photos, even when you're, chugging through data, taking our coral pieces into the metabolomics. Even underwater, we see note-taking, and it's a very serious, objectively portrayed thing when it comes to scientists. But quite frankly, that's not the way it is, and that's the way we teach our children. That's the way that children see science in the classroom for the most part. But at the end of the day, I go out on these expeditions with my fellow researchers, and we're having a really good time. We're a group of people that love the same thing enough to make a career out of it, and we're able to spend time on it and enjoy and learn and be able to enjoy ourselves in an ecosystem that we're absolutely fascinated with. This is actually that coral that I was talking about that has a coral reef on top of it, and you can see the excitement to find a coral that old. And it's all smiles, it's all fun. We have days off, we get to enjoy ourselves. And I think we need to start telling our children that whatever you're interested in, you can make a real career out of that, and you can do so with other people that share those same interests. And there's underwater high fives, and every now and then we get an underwater slate that looks like that. Now, the last portion is that hope is one of the most important things that we have. And again, there's hope in the science realm, and then there's hope in our world. Part of what I do is I go out to these dead reefs, and you'll see here, this is all devastated by the 2016 bleaching event, but there is a survivor there. And what we do is we go out and we go to these devastated reefs and we collect those survivors. They obviously have a story to tell, and we want to know why they were able to cope with what happened when everything else around them wasn't able to do the same thing. We take those corals, put them on our boat, and then we take them to a small little airport in northern Australia, fly them back to our laboratory, and basically we force those corals to breed with each other. The idea being if mom and dad both survived, then the baby corals that we can create with them should have some genetic disposition to help them into the future. And then the next stage is going to be how can we get those corals to populate massive areas so that we can get those good genetics at a population level within the ecosystem. And secondarily, yeah?
Have you used coral and bacteria in symbiotic relationships with each other?
Yeah, for sure. So one of the ironies of an event like this is that it's kicked the door wide open for researchers within the coral reef community. And the microbiome side of things we're really only beginning to scratch the surface of. So much of our research has been focused on the interactions of the coral and its symbiont, aka the algae, and how do they handshake, right? So if we're genetically changing one of those, what's the impact on the opposite side of that relationship? But from the microbiology side of things and the bacteria and the fungal components, we're just scratching the surface. But we do believe that there's something there, and I know for certain that the bacterial components do change during a bleaching event. Yeah. But we don't know enough yet, but we're getting there. The reproductive strategies of corals are absolutely fascinating. Does anybody in here know how corals reproduce? Yeah, for sure. So it's essentially called a spawning event. So the way that this works actually fascinating because they don't just spawn here and there. They all spawn on one night. On the full moon in November, this happens in Australia. It's actually different in the Caribbean, more like August. But in November, the first full moon, every single coral species in Australia is going to throw its eggs and sperm into the water column. So we're talking about trillions, unfathomable numbers of eggs and sperm being thrown out into that water column on one single night. Now going further, they do this chronologically. Species 1 goes at 6 o'clock, species 2 goes at 6:05, species 3 goes at 6:10, and it does this for 480 or so species in one single night, and those can now travel anywhere in the world through the ocean currents. And the best example of this is the Hawaiian Islands. Hawaiian Islands are a volcano. They're about 60 million years old. They shouldn't have coral reefs. How did the corals get there? They didn't just pop up out of the volcano. Well, it's because there are babies from Indonesia or Australia that have floated all the way up the currents across Asia and landed on a nice little surface that they found in Hawaii. They are perfectly adapted to take care of themselves if given an opportunity. Coral reefs that, like we saw, stayed safe in 2016, as they're reproducing, we're already seeing on these degraded reefs little tiny babies. That coral is smaller than the size of your pinky nail, and it was there in 2017, not even 365 days after the bleaching event. So they're replenishing themselves actively and unbelievably effectively. It's just that we need to protect them because of the frequency of bleaching. These baby corals don't have a chance if the bleaching comes in that next year. This is another photo of small recruitment. This is 5 different species of corals that are basically living in the size of one of your average smartphone. So they are recruiting actively, and these reefs can replenish themselves quite quickly given the opportunity. And lastly, I think that it's the youth and our next coming of generations. VR is something that I use all of the time. Part of this project actually started with using virtual reality for scientific purposes. We use something called transect lines to kind of determine diversity, et cetera, on a coral reef. So it's a scuba diver that has a 50-meter segment of rope, and we swim along the rope and we count corals and fish, et cetera. Now we can do that with a giant camera where we can swim a couple miles and have a 360 image being taken every 3 seconds, and then go back and have all of that done by computers and get a really good sense of how that ecosystem is doing. And all of that imagery, after we did it for science, we reached out to Google, and Google Street View actually started Google Ocean View. So now if you go onto any of these, if you start any of these like VR applications like Google Expeditions, et cetera, a lot of our footage from the making of this film is still some of the #1 footage seen in classrooms. So they can go on a virtual dive anywhere in the world at any point in time without ever getting wet. For a place like Colorado, it's a game changer. And secondarily, getting them out in the field, right? I'm a firm believer that experiential learning is the best form of learning. If you do something, you're learning something. It's much harder to learn something from a book. So my nonprofit actually takes students out all over the world. We install some of our cameras, et cetera, and participate in things like beach cleanups. There is not a single portion of this ocean that doesn't have plastic in it. I've been on some of the most remote places you could imagine out in the Pacific that people may not have been to for years and years and years, and there's trash everywhere. I've found televisions, I've found hard hats, I've found fire extinguishers. I mean, you name it, you can find it on the most remote beach that you could ever imagine. And secondarily, the biggest takeaway for me in this entire experience, I'm a scientist by trade, I'm not artistic. I like taking photos, that's about as deep as my artsiness goes. Had you reached out to me 5, 6 years ago and had an art project, I probably would have told you to get out of my office, and that I regret that deeply, because the bridge between science and art is one of the strongest, most important things that we have today, and that's seen through film, it's seen through artwork, sculpture, et cetera. That, as a collaborative thing to teach our children in the next generation, is that not everybody's going to become a scientist, not everybody's going to become an artist, but whatever skill set you do have, you can bring full circle to something you care about. And bridging those two and being able to take the scientists that may not be the best communicators in the world and give them to the artists who are amazing communicators in creative ways, that in itself can make the biggest difference in my mind. And secondarily, using your voice. I'm not one to stand up here and get political, et cetera, but kids have the largest voices, our politicians, et cetera. They listen to kids. Kids are welcome all the time, and they have a much bigger voice than I think they're given credit for, and the best example of this is what Greta Thunberg's been able to do, right? She's been able to start a huge, huge movement in Europe, and has started to spill over into the Americas as well. At that, one last little plug for my own work. This is my nonprofit based up in Boulder. It's called the Ocean Blueprint. Basically, the idea is to bridge all of those things together. The science is incredibly important, but if the science isn't backed up by our own actions, it's all for naught. We have to be able to include our students in real research and be able to actively allow them to be a participant in the fight for our climate and fight for our environments rather than just using their voice. So our idea is to use our camera systems. Most of our cameras, unlike Chasing Coral, are live streaming. We have them all over the world. They're essentially observatories into a coral reef ecosystem, and we bring those into the classroom to allow kids to actually dive into that data, whether it's diversity or abundance. It's students who are actively gathering the data and keeping an eye on our coral reefs long term. So that's what we're up to nowadays. And that's really all I have in the presentation end, but I'm really excited to have a discussion with all of you.